Okay, so now we're going to talk about how to make a graph. This is for Excel. So if you're going to be using sheets, I'll make another movie for that. So for Excel, what you're going to do is you're going to open a spreadsheet program, and down at the bottom, you see this little plus sign? That's where you can add extra sheets, okay? And they're just literally blank sheets of paper, but I'm not going to worry about using those. What I'm going to do is I'm going to put one, this would be sheet 1, you put in your scale readings for the mercury and the known values. This is where you match it up on the data. A couple of things you should know. If you highlight the column up here at the letter A, what you can do, let's see here, it's probably under home. You're going to wrap the text or unwrap the text. Let me show you what it looks like when you unwrap it. See how it doesn't all fit in there? If you highlight the column and you go under home and wrap text, what it does is it makes it fit in that screen. I wish I could make this a little bit bigger, but I just don't seem to be able to do that. Maybe I'll scale it down. There we go. So put your scale ratings in, put your known values in. In A1, you're going to call it scale ratings. B1, you're going to call it known values. Remember, A is referring to the column, 1 is referring to the row. And then you just put in the numbers, and let's not worry about sig figs or anything like that. And no letters, okay, in the numbers. Excel does not handle numbers and letters well. And what you're going to do is you're going to highlight these data points, and you're going to insert a chart. Okay, so on my version of Excel, which I'm not sure which it is, you're going to insert under charts this thing that looks like a scatter plot. And I don't want you to connect the dots. Okay, I want you to have that. Okay, now there's a couple of things we're going to talk about. First of all, scale readings on the x-axis, wavelengths on the y-axis. So what we need to do is we need to label our chart. So the first thing we're going to label is we're going to give it a title. And so I have a keyboard here. Let's see how well this works. It needs to wake up. And this is going to be, we're going to call this calibration curve. Let's try spelling for mercury. Okay, so it has a title. And then you also need to adjust the graph so you can say what are on different axes. So it's either under design, yep, it's under design in Excel. Add chart element. And I want to give a title to the horizontal axis. Now the horizontal axis is only my scale readings. Oh, undo, undo, undo. Oh my God. Ah, crap. All right, let's try that again. We're going to insert a chart. What was that? All right. Insert scatter plot. Okay, give it a title. So, calibration curve for mercury. And then you're going to give it under design, chart element. You're going to add an axis title. Horizontal, we're going to call that scale reading. Doesn't have units. Okay. And then we're going to go back to design, and now we're going to add a vertical title, and this would be wavelength, and this is measured in nanometers. Okay, so now I've got my graph label, but there's something I want you to notice about this graph. If you notice, all of my data is kind of in this top right end of it. And so in order to make your graph look good, one of the things you want to do is adjust the axis. And so if you right click, format the axis, I don't want the minimum value to be 0. I would like the minimum value to be, say, maybe 3.5. Because what that'll do is it'll expand my graph horizontally. See how it did that? I'm going to do the same thing on the y-axis. I'm going to adjust the axis there. Right click on it. Let's close that. Let's try again. Right click. It's hard to do this with a pencil thing. All right, minimum value again. I don't want it to be 0. I'm going to say 350. And that's going to expand it vertically. See how it did that? It's pretty awesome. Okay, it makes your graph look a little bit better. It looks a little bit nicer. Now, the other thing you're going to do, and this is the big thing. We need to come up with the whole point of this calibration curve is to take whatever spectroscope you are using and take your eyes and correct them to the accepted values for mercury. And so what you're going to do is you're going to come up with a line of best fit that's going to coordinate between your scale readings and your wavelengths, the known values. So what you're going to do is you're going to find a trend line. And so on Excel, you right click on a data point, you're going to add a trend line. It's going to be linear. Now if you look, most of my data is pretty close to that line, but it's not perfect, and that's okay. It's in a way of correcting your data. I want you to display the equation and display the R-squared value. So let's talk about what those mean. Okay, I'm going to move them over here. The R-squared value tells you how good your line is to being a perfect line, or your data is. So you see I've got a few points that are off, and I actually only have one point that's sitting kind of completely on the line, but this is the best fit line, meaning that's the one where most of them are as close as possible to the actual line. Okay? And then I want to talk a little bit about what this y equals represents. Now keep in mind, I know it's been a long time for some of you guys since you've been in algebra, but the y-axis here represents wavelength, the x-axis here represents scale reading. And what that does is it takes your scale reading, anything you read with your scope and your eyes, and you put it into this equation and it fixes your data. And it sets it to the accepted value. And so it's called a calibration curve because what it's doing is it's calibrating your data. It's making your data better. Okay? So you need this. The only purpose of this is to come up with that equation for the line and your R-squared value. That's it. Okay, now in the other sheets, and so I have another sheet over here, what you're going to do is you're going to put in all the data for everything you guys have come up with. So in cell A1, you're going to put your name. In D1, which period you're in. And then in A4, I want you to call element. B4 is spectral line color. C4 is spectroscope scale reading. D4 is calculated wavelength in nanometers. Calculated wavelength in meters, Planck's constant, and energy. Okay? And remember, if you type it in and it looks like, I don't know where it went. Let's go back. So if I go to home, I don't know what happened to it, but it was here somewhere. Oh, I have to highlight the whole column. Should be in there somewhere. You want to wrap the text. I don't know what happened to it. It was here, and now it's gone. Maybe I need to make it bigger. There it is. Okay, so if it doesn't all fit, so that used to say spectroscope scale reading, it was stacked on top of itself. You hit wrap text, and it does that. Okay, it's easier, and it will be easier for you guys in the long run if you do it that way, as opposed to making the graph wider or the cells wider, because you're going to waste a lot of paper, and we don't want to do that. Okay, so you're going to put in every element you looked at, and these are just the 4 that I pulled data on. You were supposed to look at 4. You're going to put in the colors, okay, but the important thing is you're going to put in your scale readings, okay, and whatever you thought they were. Now keep in mind, the whole point of making that graph on the previous slide was to create that equation for your line. So we're going to use that right here. Okay, that equation for your line, and you're going to want to write that down somewhere. I'm going to flip back and forth, but you're going to want to write that down. You're going to use that to correct these scale readings to accepted values. Okay, so what you're going to type in cell D5. So I want you to type in the equals button first. Very important to include that. Otherwise, Excel doesn't know what to do. Then you're going to type in your equation. So mine was 94.289. So, oops, go backwards. I don't want that. 94.289. And then my equation multiplied times x. Now let's think about what our graph represents. On the y-axis is the wavelength in nanometers, that data point. On the x-axis, horizontally, is the scale reading. So all I'm going to do is I'm going to type in that number. Equals 94.289, and it's multiplied times x. So I'm going to type in that number there. And then I'm going to go back and I'm going to look at what my y-intercept is. 27.012, and it's positive. And again, I have to erase this because it doesn't like that. times. Ah, God, that is really annoying. I don't like not having a mouse. Whatever. Get rid of that. And then plus 27.012. That's why it's an advantage to actually write it down. Okay, so what I did is I put in my equation y equals slope times my x-axis value plus the y-intercept, and I'm going to hit enter. Now you might think that's a pain in the neck, but here's the really cool thing. Once you've done it once, you can automatically populate every cell with that data by grabbing that little square at the bottom. What that will do is it's going to drag that equation down and substitute in every value you have. Okay, so let me show you how it works. So you just grab that little square, drag it all the way down to the bottom of your data, and there you go. Now I want you to notice a couple of things. The very first data point I put in was 4, and I got 404.168. And look at that, 404.168. So my data points match because it's using that linear equation to calculate the wavelength. Now I want to point out this one, 27.012. Well, that was my y-intercept. And the reason why is because my value for x is 0. So I'm just going to delete that because that actually isn't a point. And if you notice, it's the same thing here, and it's the same thing here. Okay? And that's what I have. Okay? Now to do the calculated wavelength in meters, if you remember, you're going to type in equals, and you're going to take that wavelength in nanometers, and you're going to multiply by e to the negative 9. And that's the minus sign. Okay? Hit enter. Now, what happened here? Maybe I need to put in a 1. There we go. 1e negative 9. Okay? And again, take that little square, drag it all the way to the bottom. I didn't do it. I don't like not having a mouse. There you go. And again, I'm going to get rid of the ones that are the zeros because they're not important. Okay. Then in here, I'm going to have you put Planck's constant. And that's the same number for every one of them. So it's equals 6.626 e negative 34. Enter. And it's the same value all the way down because that's finding, this is going to help us find the energy for each of the waves that we found. Okay. And then to find the energy, you're going to take h, Planck's constant, times c, speed of light, divided by the wavelength. So you're going to do equals Planck's constant times the speed of light, 3e to the 8th, divided by, and then that's the wavelength, but the wavelength has to be in meters. That value, hit enter. And that tells you the energy of every wave that you guys saw. And again, I'm going to get a bunch of zeros, because you can't divide by 0. A bunch of unhappy cells. I'm going to get rid of them. So that's how you fill in your chart. Okay? It is a little bit tricky, but Excel is wonderful at doing a lot of calculations very quickly. Now, if you want to go through and adjust your sig figs, so for this one, I would say probably no more than 3 sig figs. So I would say general, and I would say number, and I would say, remember, less zeros is this number right there. Okay, and then here, same thing on this cell. Here at the top, under a number, scientific notation, I would get rid of one of your decimals. 3 sig figs. Okay, and then everything else has 3 sig figs. And so that's how your data. So what you're going to print out is you're going to print out your graph. Make sure it's all labeled. Okay, all your data points are in there. You've got your r² value and your y value. And you're going to print out this. And remember, you can adjust the width of the graph to make the lines a little smaller so you can get it all on one page. Okay, maybe not quite that small because spectroscope should be one word. But it's the idea is you want to kind of minimize how much paper you're using. Maybe you need to use a landscape printout, whatever. Okay, so that's how you use Excel.